Birds accomplish this in much the same way as humans do when they make sounds. They create vibrations that travel through the air. In the case of humans, we create vibrations in our pharynx, specifically the area of the throat just above the windpipe, where the vocal cords are. These cords are really just folds of tissue that vibrate when air passes by them, much like the schoolyard trick of blowing across a piece of grass. The air makes the grass vibrate, creating a high-pitched sound. Now, if we turn the throat on end for a moment, we can see a bit better how vibrations and ultimately sound is produced. When air from the lungs is forced across the vocal cords, vibrations occur. These vibrations literally squeeze the air, creating areas of compression. These areas of air compression carry energy. These energy-carrying compressions travel from place to place, transmitting that energy. For example, when they smash into an eardrum and are heard as sound. Different sizes of compressions account for louder or softer sounds. We can see that here in this spring. A small compression would be a soft sound, while a bigger compression would be a louder sound. It's also important to realize that sound waves are longitudinal waves. They compress and vibrate in the same direction as they travel. Note also that it is not the medium that moves, only the vibration. Here, the compression in the spring moves from one end of the spring to the other, but the spring itself does not go anywhere. It's the same for sound waves that are generated in air. The vibrations travel via vibration of air particles, but the air itself does not travel from place to place. Now, if you generate a series of sound waves in the air, such as those we see here traveling left to right in this simulation, you generate a particular tone. If we want to change the tone, we simply generate the sound waves at a different frequency. Higher frequencies mean higher pitched sounds. And how quickly is all of this happening? Well, if the sound is traveling in air, it's moving at about 343 meters per second or 768 miles per hour. You may have heard of a sonic boom before. That's generated when an object, such as a fighter jet, breaks the sound barrier and travels faster than the speed of sound. Such fast jets actually travel faster than the vibrating compressions of the sound in the air.